All right, good afternoon, all. Today we are going to be looking at domain of functions, how to find domain of functions. One of the challenges that students have in Math 102 calculus is on how to find domain of functions. So today I'll be putting us through with different examples on how to find domain of functions. All right, so first of all, let's define what the domain of a function is. All right. This we have here is the definition of the domain of a function. The domain of a function is defined as all possible values of x, the input that makes a function define. This is how we define the domain of a function. They are all the possible values of x that when you impute into a given function, it makes that function define. And the values of x are called the input. All right. When we have a number line, negative infinity, positive infinity, 0. This is the set of all real numbers, the set of all real numbers that runs from negative infinity to positive infinity. All right. So any value of x you pick from this number line system and you impute or insert it into a function and it gives you a value, all right, that is the domain of that function. All right. It makes a function define. That's how we define the domain of a function. Okay, having known what the definition of a domain is, we will now take some examples on how to determine the domain of a function. Mind you, there are some certain restrictions that you must obey. There are some certain laws you must obey if you are to find the domain of functions. All right, we have the polynomial function, the rational function, the radical function, and the rest of them like that. All right, the transcendental function and all have you there. So these are different functions, and each of those kind of function they have restrictions on what you must know to before you find their domain. So let's take an example, starting with the polynomial kind of functions. All right. What we have here, these are polynomial functions. All right. Polynomial functions are functions of this nature, where you have the highest power of the unknown variable there decreasing as you go to other terms. All right. These are polynomial functions, and this is how you know polynomial functions. Now, how do we find the domain of the given function? Remember, we said that the domain of a function is defined as all possible values of x, the inputs that makes a function defined. In other words, when you pick from the number line system, you pick um, some values of x and you impute it into this function. When you impute that value of x into the function and it gives you an answer, it makes that function defined, then we say those values are the domain of that given function. So let's pick the first polynomial function, all right? let's determine the domain of this given polynomial function. For the first one we have here, f of x is equal to 2x minus 6. How do you determine the domain of this function now? All right. Like I said, this is your number line system from negative infinity, 0, to positive infinity. Now, these parts here, they are all negative real numbers, positive real numbers. When you pick from this region, let's assume we have here minus 3, minus 2, minus 1, and we have 1, 2, and 3. Now, any of this value of x that when you pick from here and impute it into this function, that's why it is called impute. It is what you are fixing inside the function. That's why it's called impute. So any of this value you impute into this function gives you a value, makes that function defined. That is the domain. That set is the domain of the given function. Let's try and see if picking any of these values here will make this function defined. Let's pick negative 2 and insert it into this function and see. F at x equal to negative 2. Let's look at this now. At x equal to negative 2, let's insert negative 2 into this function. That is, we'll find f of negative 2. Whenever you see x, insert a negative 2 there, minus 6. 2 into minus 2 will give us negative 4 minus 6, which gives us negative 10. So you see that at point x as minus 2, our function gave us minus 10. That is, it is defined. You get it now? It is defined. If you still pick other numbers from the positive real numbers, let's pick x equal to 3, positive 3. At x equal to 3, f of 3 will be equal to 2 into 3 minus 6, which is 6 minus 6 equal to 0. Now you see that picking from the negative real number and picking from the positive real number, this gave us negative 10, that's minus 10, and this gave us 0. What does that tell you? Any number you pick from this region and you insert here, whether positive numbers or negative numbers, and you insert them here, it will give you defined values. Your answer will be a defined value. It means that that function is defined at all points on your real number line. These are all polynomial functions. Question 1 and question 2, they are all polynomial functions. And any value you impute, we picked negative 2 at first, it gave us negative 10, defined value. We picked positive 3 from the positive real number, gave us 0. If you pick 1, insert 1 here, 2 times 1, 2. 2 minus 6 will give us negative 4, that's minus 4. So at every point on this real number line, our function 2x minus 6 is defined. What does that tell you about the domain of polynomial function? It means that the domain of all polynomial function is the set of all real numbers. Because when you keep imputing, pick negative 100, negative 50, positive 100, positive 50, insert it here, you will have a defined value. Pick 1,000, pick negative 1,000, insert it here to give you a value. So it means that at every point on this real numbers line system, this function is defined, which will now conclude that, therefore, the domain d of f, that's how we denote domain of a function. The domain of 2x minus 6 is the set of all real number, which we can write as d of f equal to negative infinity to positive infinity. All right, so this is the domain of a polynomial function. So we can conclude that, therefore, the domain of all polynomial functions is the set of all real number. This is the domain of all polynomial functions. So whenever you say a polynomial function, even if it is having x raised to the power of 5 and the power of x keeps reducing, they are all polynomial function. How you know a polynomial function is when the unknown variable there has its powers decreasing. Here, the power here was 2, 1, 0. That's a polynomial function. The highest power of x here, 1, here, 0, is a polynomial function. So whenever you see polynomial function, the domain is the same, the set of all real numbers. All right, so this is how you find domain of polynomial functions. Thank you. Okay, so what we have here are all rational functions. Determine the domain of the functions. How do you know a rational function? You see, these are some of the skills you should master. You need to master how to identify functions. The previous example I solved in my other video, they were all polynomial functions. And I told you how to identify polynomial functions when you see them, right? Polynomial functions are functions in which the power of the variable there decreases. That's polynomial function. Example, x squared minus x plus 6, polynomial function. Now, what you have here is a rational function. A rational function is a function that has a numerator and a denominator. That is, there's something up there and something down there. That is a rational function. Now, to find the domain of rational function, it has a restriction that you must know. That is the law you must not break for rational functions. Let's pick the first example, then I'll explain to you how this applies.